Hello, hello. Today I'll be going over trigonometry. I know it's been a while since I've uploaded, but I figured I might as well get back into it? So let's go over the first question. So it says, by expanding cosine x plus 45 degrees, express that minus 2 sine x in the form of r cosine x plus a, where r is greater than 0 and 0 is less than a, less than 90. Give the value of r corrected for significant figures and the value of a corrected 2 decimal places. So I forgot to say in the beginning, but in your formula sheet, which I have right over here, there's this whole trigonometry section. Let me put the draw tool on. This whole thing. That's so helpful when it comes to this section. This one was from last year. Tangent equals sine over cosine, and cosine squared plus sine squared equals 1 was also from last year, but they are still used in the new stuff, right? But all of this is new, right? Today we'll be going over all the addition and subtraction ones. I'm also pretty sure we go over the double angle ones, but we aren't really going over the tangent, secant, or the cotangent, cosecant. But if you do want to see a video of me covering those, just let me know down in the comments, and I will certainly go over it. But today we are doing the addition and multiplication ones. So the one I see that seems really relevant here is this one right here, where it has cosine a plus b, and I had a cosine x plus a, so I'll be going over that one. Because this is cosine x plus a, they have an r in front. That means I distribute r to all of my terms. What I mean is that I'm going to have, let me get a draw, r, then I'm going to have cosine a times cosine b, so that's going to be my first term and my second term respectively. Cosine x times cosine a. And it's really interesting what they have for this chapter. They have plus minus, like you see for the sine situation, but they also have minus plus for the cosine situation. This means you'll use the opposite of what is said. If there's addition, you will use subtraction, and if there's subtraction, you will use addition. So I'll have minus sine of x, sine of a, right? You see how I have parentheses for all that because that's directly what the cosine means, but I still have the r right in front of it. This means I have to distribute the r to both of my terms. So I have r cosine x, cosine a, minus r sine x, sine a. Ooh, there, it got a little messy at the end there, but it still works out. Now, I don't know about you, but from here, I'm not really sure what to do. I have a bunch of letters, bunch of variables, bunch of cosines and sines. I'm not sure what to do. But they said to expand this to look like that. And I have this overall equation here, right? So I'm going to, because it says by first expanding, I'm going to try expanding it. I have cosine x plus 45, which is really similar to the one I have on the right. So I'm going to have cosine x, cosine 45, and that is going to be minus, because it was the minus plus, not the plus minus. Sine x, sine 45. I try to create little lines so it's a little clearer. And now, cosine 45 and sine 45 both have values, so I can simplify them in this equation. So I just put those in my calculator. The cosine of 45 is 0.71, about, not exactly, but just about. And then sine 45 is also 0.71. So instead of writing sine 45 and cosine 45, I'm just going to write the values in front because these are multiplying. So it's almost like I can shuffle a little bit. For example, let's say cosine 45 was just 3, right? I could write cosine x times 3, or I can write 3 cosine x, which is sort of a neater format. It's a little easier to work with, so I'm just going to write like that, except that equals 0.71. But also, it's important to remember that I have minus square root 2 sine x. Oh, I wrote that backwards. I had a square root 2 sine x. This pretty much, because I have sine x, I'm going to combine these two terms. So I have 0.71 cosine, then negative 0.71 minus square root 2. I just put that in the calculator. That gives me negative 2.12. So minus 2.12 sine x. Just like that. And now I notice that, well, they tell me these two equations are equivalent, right? So this one has cosine x, this one has cosine x, this one has sine x, this one has sine x. This means r sine A will be equivalent to 2.12. This also means r cosine A will be equivalent to 0.71. Because if I multiply those two values, I have to get that value right there. So I'm going to erase all my messy little lines. And now I'm going to equate them to each other. So I have r cosine A is equivalent to 0.71, and r sine of A is equal to 2.12. And I don't need to use negative 2.12 in this case because I have subtraction here and subtraction here. So if I made it negative, it's almost like saying that there was a plus sign right here. And that is not the situation. Oh, I erased the minus sign. So now I see two variables in one equation. I don't like that. Two variables, one equation. I can't really solve that. I do have two variables, which you might say use substitution, but substitution, it gets a little messy in this situation. So what we're going to do, I know sine over cosine makes tangent, so I'm going to do that. R sine A over R cosine A will equal 2.12 over 0.71 because those are the respective values. Now, r over r is going to cancel out. If I had 3 over 3, it would cancel out, so r would also cancel out. Then I have sine over cosine, which is tangent. So tangent A would equal 2.12 over 0.71. I just put that in my calculator. That would give me tangent A equals 3. And if I take the inverse tangent on both sides, I would get 71.57 degrees. 71.57 degrees. And that is our A, where A is to 2 decimal places. But that's not all they asked me. They also say to give the value of R. Well, I previously had this equation, well, two equations actually, that have R and A linked together. Because I now know what what A is, I can replug it in and then solve for R. So I think I might scroll down a little bit, give myself a little bit more room. You can use the first one or the second one. I'm just going to use the first one because it's first. R cosine of alpha, which is 71.57, equals 0.71. To solve this, I would divide by cosine 71.57 on both sides. So R equals 0.71 divided by cosine 71.57. For this one, remember to do normal cosine and not the inverse cosine. We only do inverse cosine when we're trying to get rid of cosine on one side, but in this one, we're just moving the cosine. There's definitely a difference between the two. So R equals, I did the math a little bit earlier, it equals 2.235. And those are our 4 significant figures. So there's 1, and there's 2, and that's 5 marks. Now, I'm going to just erase a little bit of my work, that way I have a little bit of more room to work with. Of course, you want to see it again, you just rewind back in the video. So now I say hence solve the equation. Already, hence, the word means you're pretty much using what you used previously. So if they said by expanding this into r cosine x plus a, that means I'm using r cosine x plus a to solve this. Now, previously in trigonometry, if you didn't get the first part, you can still use that, because it'd be like, rephrase it so it's sine squared equals x or something. And then you could use sine squared equals x in the bottom. But because they have r, x, and a, you would need to find a and r in order to do the 4 marks. So it's almost like if you don't get those 5 above, you can't really get the 4 down below. Which sort of sucks, but maybe you can just say r equals this, a equals this, and like pretend to solve it. I'm not entirely sure how that would work. You might get like some m1s here and there. So I have r cosine x plus a, which r is 2.235, cosine x plus a, which is 71.57. Oh, by the way, I forgot to mention earlier, the reason why I put this in degrees is because I saw the next question had degrees. You don't necessarily have to do this, as you can just like redo some of the math and put it into radians again. But I think it's like convenient to like acknowledge that. So now, because they tell me it was equal to 2, I'm going to set it equal to 2. And now I can also erase my r down here. I just knew that we needed that, so I kept it there. There we go. And now we're going to solve like it's a normal equation. First, well, I want to get x by itself in general. So first, I have to divide by 2.235. So cosine of x plus 71.57 will equal 2 over 2.235. Then I'm going to take the inverse cosine on both sides. So inverse cosine 2 over 2.235. Sorry, my numbers are getting a little messy there. And now I'm going to solve for what that inverse cosine value is by putting in my calculator mostly. So I get that it was 26.51. X plus 71.57 equals 26.51. And now, sort of weird to explain. Honestly, you have to trust a little bit. One of my answers is going to be subtracting 71.57. But you know how cosine, sine, all that kind of stuff has two different answers? I'm going to base my two answers off of this value, not the value I get after subtraction. This is because the 71.57 was inside the parentheses. That means I'm taking like the cosine of x plus that value, not when it's subtracted. Well, not when it's like subtracted. I mean like subtracted from both sides pretty much. But because I'm taking cosine of that entire value, I have to consider both my answers before I do that. So 26.51. All seniors turn crazy, or all students trust Cambridge. 26.51, if this is 90, this is 0. It falls right over here. And where cosine is still positive, it falls right over here. So I'm going to find the distance between here and here. The distance is 26.51. So I'm going to do 360 minus 26.51. From there, I get 333.49. So x plus 71.57 equals 333.49. And now I have my two equations I can finally solve for. This one, I'm going to be subtracting the 71.57. Same with the other one, but I'm showing you each answer step by step. So 26.51 minus 71.57. That gives me negative 45.06, which I can't have a negative answer. In the values, they gave me 0 to 360. The way I can solve this is by adding 360 to it. As if I have my little circle, this angle right here is going to be the same angle as this angle right here if I make like a full revolution. So add 360, I get 314.94. That is my first answer. And then I have 333.49. Oh, I missed a 3. Minus 71.57, which gives me 261.92. And those are my two answers. Oh, small thing I just realized. You shouldn't write the 4 because degrees should always be to 1 decimal point. So there we go. I mean, we're still right. They probably would have given you the mark because you were just like one significant figure out, but either way, it's always a good thing to be knowledgeable of. That radians are to 3 significant figures or like the perfect fraction, and degrees are 1 decimal point. Okie dokie, so our next one is really, really similar, where we're putting something cosine to sine x into the form of that cosine with our mysterious r and our mysterious a. And we have to give the value of a corrected 2 decimal places. So in this one, they don't ask for r right away, so it's only worth 3 marks compared to the previous 5 marks. But still, it's going to be the exact same steps, we're just not going to include the r steps. So, first I'm going to expand this. This is going to be r times cosine x, cosine a. Then because it's minus plus, we're going to write a plus instead of a minus. Sine x, sine a, just like that. Then I'm going to distribute both my r's to here and to there. R cosine x, cosine a, plus r sine x, sine a. Now in front of the cosine x right up here, I have a radical 5. So because this term has cosine x, I'm going to have r cosine a equals radical 5. And because this one has sine x, I'm going to have r sine a equals 2, because the 2 is right at the front. To solve this, I'm going to take sine over cosine. R sine a over r cosine a, which will equal 2 over radical 5. So the r's cancel out. Sine over cosine is tangent. Tangent a equals 2 over radical 5. Then I have to take the inverse tangent on both sides. And once I do that, I get 41.81. Alpha equals 41.81. Oh, by the way, I want to add the detail that I know I said earlier that degrees are till 1 decimal point. That's only if they don't tell you something like 2 decimal points. If they tell you 2, use 2. If they tell you 5, use 5. But if they don't tell you anything, you assume 1. Cambridge is really weird like that. But anyway, we got 41.81 degrees. Because our next question is in degrees, so it's really helpful just to keep it like that. Next, we need to solve the equation radical 5 cosine 1 over 2x plus 2 sine 1 over 2x equals 1.2. The only difference between our first equation, right up here, and the second equation right here, is that they have the pesky 1/2. And I'll be honest, we'll worry about that 1/2 when we get there. The first thing we need to think of is that since it says hence, that means we're using our r cosine x minus a. But this one, we only know a and not our r. It's really unfortunate because you still have to find r, but this time they just don't give you marks for it, which like really stinks, but whatever, we'll still do it. To find r, we plug it back in, right? So I have r sine a equals 2. So I'm going to do r sine 41.81 equals 2. You can use either equation. I just saw that that one didn't have a radical, so it might have been easier to deal with. I'm going to divide by my sine 41.81 on both sides. R equals 2 over sine 41.81. As also, those are both numerical values, so I can just divide those in my calculator. Oh, that actually led me like 3.0000. That's like a really nice number. So R in this case is 3. It's always nice when you get like a full number. Makes you feel like you're right. So now we have our R cosine x minus a. We're going to have 3 cosine. And because they have a 1/2 x, we need to have 1/2 right in front. The reason why this 1/2 isn't distributed to the a is because a, the cosine of a times r would equal that square root 5. That square root 5 wasn't changed, therefore the a is not changed. So now we have to solve. Is that all I have to do? Hold on, let me think for a second. Yeah, I'm pretty sure it's all we have to do. We just have to set it like that. Because I looked back at my previous work and I still got the right answer. For some reason, I didn't have to account for that whole thingy. But I think it's because, oh, I know why now. It's because that whole phrase, all that entirely, equals r cosine x minus a. So I don't have to think at all about that sine 1/2 x because it's inherently included in what I already have. I just put that in my calculator. I got 66.4. Of course, a bunch of extra numbers at the end, but I'm just writing down one figure for the sense of the paper. 1/2 x minus a would be equivalent to 66.4. I'm also going to have another answer, and I have to consider that other answer before I do anything inside those pesky parentheses. So I have all seniors turn crazy. My a is right over here between 0 and 90. And my other answer is going to be between 270 and 360, because that's where cosine is also always positive. So I have to do 360 minus my previous answer, which is 293.6. So 1/2 x minus a. Oh, I do know a. A is 41.81. I just forgot to write that, I guess. Equals 293.6. So I guess I'll just write over it right now. 41.81. God, that is messy. 41.81. That's right there. So now I can just solve this like an algebraic equation. I can add 41.2 on both sides. So I'll take my long number. and add 41.81. I feel like I said a different number out loud. Maybe I did. So this goes right here. 1/2 x equals 108.2. And my other one is 1/2 x equals, let me add it up. What was it? 41.81. And I get 335.4. Then I'm going to multiply by 2 on both sides, because if you have a fraction, you can multiply by the denominator to cancel out. So my first x, all of that, times 2, will give me 216.5. It was 4/6 by rounded up. And this one is going to be 335.4 times 2, which gives me 670.8. And because that degree is over 360, I can subtract 360 from it to get the same kind of angle. And from that, I get 310.8. So those are my two answers. Boop. Now I'm going to erase all my work, because I know I sort of wrote over question 3, and question 3 is separate from question 2, so I don't need any of my stuffy stuff. We love cleaning up the page. God, if only I could do this on the AICE exam. Sort of sucks we have to write in pen, but oh well. Now I need to solve the equation that sine theta equals 2 cosine 2 theta plus 1, giving all solutions. That's an interesting phrase. And the interval of between 0 and 360. So I'm still working in degrees. That's really important. And this is for 6 marks. That's a lot of marks. So we got to be very careful while we're doing. Make sure we give all of those solutions, because all seems like a really key word there. So I'm going to rewrite my thingy. Oh, sine theta, actually. Except I notice I have cosine 2 theta. That seems really relevant to me, because on my formula sheet, I have, or is it cosine 2a, in which in this case, a is theta. And I notice I have sine earlier on in my equation. I notice cosine and sine, I notice cosine. I also notice an answer that has only sine in it. 1 minus 2 sine squared. 1 minus 2 sine squared theta. And there's a little plus 1 at the end. So plus 1. The reason why I put all that in parentheses is because I have a 2 that multiplies with it. So if cosine 2 theta equals 2 terms, I need to multiply each of those terms by the 2, aka distributive property. Sine theta equals 2 minus 4 sine squared theta. I'll make sure that, yeah, there we go. So now I can add the 2 and 1. Sine theta equals 3 minus 4 sine squared theta. And now I have a quadratic, because I have sine squared and I have normal sine. If I replace sine of theta, I would replace it with s, but my s's look like 5, so I'm just going to make it x. Okie dokie. So I have x equals 3 minus 4x squared. And that looks a lot more familiar, right? So I'm going to set it equal to 0. Well, first I'm going to move this over. That way it's equal to 0 and the first term in the quadratic is positive. It's just generally easier to factor if you do it like that. So 4x squared. Then I'm going to have plus x minus 3 equals 0. So 3 only breaks up into 3 and 1. And I need my 4 to multiply with one of those terms. I'm going to multiply it with this one. Because if I multiply 4 by 3, I get 12. And if I subtract or add the 1, I would definitely not have the 1 that's the coefficient for this x. Because it's positive, I need the 1 to be positive and the 3 to be negative. So overall, I would have 4x minus 3 times x plus 1. Just like that. And of course that equals 0. And because this equals 0, I can set both equal to 0. X equals 3/4. That's messy. And x equals negative 1. But we are not done there. We are not done there. We are not done there. X is a substitute for sine theta, so I need to set both those equal to sine theta. So now because sine theta equals x, I'm going to do sine, I'll make a little line here, sine theta equals 3/4. I'll take the inverse sine on both sides, but also sine theta equals -1. I already took the sine inverse a little previously. So the first one is going to be 48.6. But we also need to find that inverse. All seniors turn crazy. My first answer is in this quadrant, as between 0 and 90. And sine is also positive in this quadrant. Wow, it's not a cosine for once. So I have to do this distance and this distance. We always go based off the x-axis for this. We can never go based off the y. So I have 48.6. That means I do 180 minus 48.6, which... I wrote down a different answer on here that... Oh, never mind. That does work. I was thinking something else for some reason. It's 131.4. Right now I have a calculator I just do not like, because I lost the one I really do love, so I just hate using it, so I wrote down the answers and stuff. Next we have sine theta equals -1, which if you just remember the unit circle, it'd be right over here. Wait, no. Is that wrong? Yes, that is wrong. Cosine, cosine. Whatever, you just put it in your calculator. I should not pretend to know things. Yeah, it was 270, because 270 is the y coordinate. So theta equals 270, and that does not have any other options. That's why I was going about the unit circle. Because sine is the y value, and cosine is your x value. So when you're at -1, you're down there on your unit circle, and there is no other value where it's -1. Let's say sine was 0 instead. If sine was 0, it could be here and here. If sine was +1, it would only be up here. But because it's only -1, it's just down there. So those are all of our solutions. That was 6 marks. Honestly, that wasn't the worst kind of work for 6 marks. By the way, sorry if my voice really isn't the best this video. I've been a little sick lately, and my voice is dying from this video, but it's awesome. It's great. We gotta express 4 sine theta minus 3 cosine theta in the form of r sine theta minus r. Theta minus a. I saw the r over there and I got tripped up. Well, we got a little sine here. In our previous questions, we've had only cosine, so our process will change a little bit, but not too much relatively. Where r is greater than that, a is between those, stating the value of a corrected 2 decimal places. Okie dokie. For sine, it is sine cosine, plus or minus cosine sine. Okay, can I switch tabs? There we go. So start with sine, right? Yeah, sine. So I'm going to have r times sine theta cosine alpha. It is plus minus, not minus plus, so I'm going to use a minus here. Then I have cosine theta, then sine alpha. So now I'm going to distribute my r to both terms. Like I said, still generally the same process. It's just what you have in the parentheses changed a little bit. But you still have 2 terms in the end, so it's all good. I wonder, does the tangent one have 2 terms? No, it just has a fraction. Oh, that's yucky to deal with. I don't think you'll ever have tangent for this kind of thing. So this one has sine theta, so this one has sine theta. So r cosine alpha is equivalent to 4. This one has cosine theta, cosine theta. R sine of alpha is equivalent to 3. Then I have sine over cosine. So sine over cosine. And now I get tangent alpha. Inverse tangent on both sides. So I have it written down. 1 second. Yes, I do. So it's alpha equals 36.87. Just like that. And I should mention, I didn't mention it earlier, but the reason why I'm only doing one answer for alpha is because alpha is between 0 and 90. That means there's only one possible quadrant, so I can't consider any of the other ones. Hypothetically, if they said there was 2 answers, yes, I would find 2 answers, but I've never seen them do that at least, so you're always finding just the one answer for these kinds of questions. So now I have, hence, solve this equation. For 4 sine theta minus 3 cosine theta equals 2, where theta is between all of those values. So before I do this, I need to know what my hence is. My hence means this r sine theta minus alpha. But I don't have r right now. It's unfortunate they didn't give me the marks for r. I might get 1 in this question, maybe. I didn't really look at the mark scheme too much. But we have to do it now. So I'm going to use my r sine A. R sine of 36.87 is equal to 3. So now I divide by sine 36.87 on both sides. Gets rid of this. So now R is equal to 5. It came out to be a nice, pretty number in the end. That's not our final answer, I just wanted to box it in. So now I'm going to go back to my R sine theta minus alpha. Now I have 5 sine theta minus 36.87. And it was equal to 2. So now I do my math. I divide by 5 on both sides. Then I take the inverse sine on both sides. Equals sine inverse of 2/5, which is sine inverse of 2/5 is 23.58. All seniors turn crazy. My answer is within this quadrant. My other answer is within this quadrant because sine is positive. So that would be distance between here and here, distance between here and here. I would do 180 minus 23.58. So our other answer is 156.42. So I have theta minus that equals that. Then I'm going to have theta minus that equals 156.42. Then I'm going to add 3687 on both sides. So 23.58 plus 36.87. One of my answers is that theta equals 60.45. 156.42 plus 36.87. Theta also equals 193.29. And because these are degrees, I should put it to 1 decimal point, so that's going to round to 5, and that's going to round to 3. And those are my 2 answers, and they both fit within my domain, so that's excellent. Our next question says to write down the greatest value of 1 over 4 sine theta minus 3 cosine theta plus 6. So it's what we had earlier, plus 6. This is like really interesting one, so to speak. So they put in a fraction, so that tells me something about fractions. Let's imagine a few values to put in there. 1 over negative 3. Well, it's going to be negative 1/3. That's not that big. That's not the greatest possible value. Let's try 1/2. That's certainly bigger. It's certainly a bigger value. What if I have negative 1? If I have negative 1 on the bottom, that would be negative 1 overall. Okay, I'm getting somewhere, right? What if I try 0? Oh, I can't divide by 0, so this whole thing cannot be equal to 0. And by whole thing, I mean what's on the bottom, right? And I was talking about with negative 3 on the bottom, negative 2 on the bottom. What if I try 1 over 1? I get 1 as a value. So far, that's my biggest value I have had possible. I had small negative, a big negative, but now I have 1, a positive whole number. Well, what if I try to put 2 at the bottom? Maybe that'd make it bigger. But now I have 1 over 2. Wait a minute, that's even smaller. Then I have 1 over 3, 1 over 4. My fraction will get continuously even smaller until I have a little sliver. So therefore, the greatest value is this being equal to 1. So therefore, this equals 1. Greatest value in general is 1. Because I can never get bigger than a fraction. You might be asking, well, Jade, what if it's decimal overall? And relatively that's impossible because the plus 6 will always imbalance that decimal. And you might be wondering if this is enough work for this question, but this is only 1 mark. So I'm pretty sure it's enough. I don't think the mark scheme said anything specifically. I think it just said 1 as the final answer. The other ones would not be accepted. I think they would accept a sentence, so maybe you could write the biggest answer is 1 because it is a fraction that will approach. I don't know how you'd word that really. That approaches even smaller fractions. You could write like that. So now we have another question that involves our cosine theta A. You already know the drill a little bit. So I'm going to have, yeah, it's literally the same exact question as the previous ones. This packet is just full of these kinds of questions because I think it's really hard to understand until you see examples of it. At least I had no idea how to do this until I saw examples. So we're gonna do it together. It's R, what is it? I'm pretty sure it's like cosine theta, cosine alpha. Then it's a minus plus, so it's a plus there. Sine theta, sine alpha. I'm going to distribute. R cosine, I should write all of it. Theta cosine alpha plus R sine theta sine alpha. And then I have my square root 6 in front of my cosine. R cosine A equals square root 6. And then I have square root 10. Here's my sine theta. R sine alpha equals square root 10. And now I can have my sine over cosine cancels out my r's. Sine over cosine is tangent. Square root 10 over square root 6, which now I can't simplify that like a perfect fraction. I just have to take the inverse tangent on both sides. I have it on my paper. I just have to flip it over. 52.24. And there we go. That's alpha for you. Corrected 2 decimal places. In the next one, we have a hence. So we know we're using our exact last answer, but we need to find r this time. So in each of the following cases, find the smallest positive angle which satisfies the equation. So I know these rules are applying to this question as well as this question. That's a bit notable. That way, if you forget, you just like won't exactly know what to do. So we need to find the smallest theta which satisfies the equation. So I have all of that, all of this right here, is equal to -4. So I know my r cosine theta minus a is equal to -4. But first, I need my r. They didn't tell me to find that, so now I need to find it on my own, and only for 2 marks. So I'm going to plug my alpha back into this one. R cosine alpha. Oh, now I did that wrong. I need to plug in alpha, that's the whole point. I think I'm still sick, honestly. But oh well, I wanted to do math today. 6, and I'm going to divide by cosine 52.24 on both sides. And for that, what do I get? I get r equals 4. Another nice, pretty number. That's nice. So now I have 4 cosine theta minus alpha, which is 52.24, equals -4. I'm going to start by dividing by 4 on both sides. Cosine of theta minus 52.24 is equivalent to -1. I'm going to take the inverse cosine on both sides. Inverse cosine of -1, I believe that'd be 180. Oh, I'm right, that's cool. 180. Now, because cosine does not have another answer for -1, because the -1's right over here, I just gotta add my 52.24 on both sides and I'm done. Because there's no other alternative. So add it over, that is 232.2. Because I have to drop the 4, so it's to 1 decimal point. And there we go. That is my smallest possible angle, because that is my only angle possible. Alrighty, last one. Woo! Let's get through it. So, this one is the same thing as the one above, except I have it equal to 3. And I also have these pesky little 1/2s in here. I'm guessing 1 extra mark is from having two answers because the last one was -1, so I only had one answer possible. And I'm guessing my other mark is from dealing with that 1/2. I just noticed it's 2 marks more. I'm not sure if that's where the marks come from. I'm just assuming because that's what's different. So I have my r cosine blah blah blah. That does not change because it was from the previous question. Except I have 1/2 theta minus 52.24. And that equals 3. So now I'm going to divide by 4 on both sides. So cosine 1/2 theta, 52.24. Honestly, trigonometry is sort of relaxing once you get the hang of it, you know? Because it's just like sometimes like the same thing every time. Maybe a bit of a puzzle. Now we take the inverse cosine on both sides. 1/2 theta minus 52.24 equals the inverse cosine of 3 over 4, which is what? 41.4. Is that right? Yes, it is. So cosine, all seniors turn crazy. All is right there. Cosine's also positive over here. So I need to do 360 minus 41.4. Best do my calculator is 318.6. So I gotta have all of this previously, and also equaled 318.6. Oh, I don't have any more room on the page. Oh, that sucks. I'm going to add 52.24 on both sides. 1/2 theta would be equal to 41.4 plus 52.24, which is 93.64. And then I have to multiply by 2 on both sides to get rid of my 1/2. I'm going to write it above, that way I have room for the other one. Theta equals 187.28, which I'm going to round to a 3. That's one of my theta answers. And my next one's from doing the other equation. So 1/2 theta equals, I'm going to add 52.24 on both sides. 318.6 plus 52.24. 370.84. And I'm going to multiply by 2 on both sides. So theta equals 741.68. I'm really running out of room here. So because they said, did they say it's between 0 and 360? I feel like it's between 0 and 360. I'm going to make it like that just in case, because often they do say that, and I do want to show you what to do. So because this is above 360, I would subtract 360. I get 381. I subtract 360 again. So I get theta equals 21.68. And I round my 6 up to a 7. 21.7 degrees. And there we go. We found our answers. We're all good. Got all those 4 marks. Thank you so much for watching. If you have any other topics you want me to cover, if you want me to cover more stuff on this, more stuff on another chapter or another section of this chapter, absolutely let me know. And I'll see you guys next time. Bye-bye.